is a place in the Russian Arctic where the ground was opened not for oil, not for war, and not for profit, but for something far more dangerous: knowledge. On the surface, it does not look like the gateway to one of the most ambitious scientific experiments in human history. There is no vast, futuristic city built around it, no glowing machinery, no endless columns of engineers marching beneath giant towers. What remains is almost unsettling in its simplicity: a sealed opening in a remote, frozen landscape on the Kola Peninsula, near Russia's border with Norway, in a region shaped by ancient rock, Arctic winds, and long silence. But beneath that silence lies a story that is far bigger than the hole itself. Because this was not just a drilling project. It was an attempt to descend into the Earth's crust deeper than any human being ever had before, to extract evidence from a world no eyes had ever seen, and to challenge assumptions that geologists thought were already settled. For nearly 2 decades, Soviet scientists pushed farther and farther downward, deeper into the ancient crust beneath the Kola Peninsula, until the borehole reached 12,262 meters, or 40,230 feet. That made it the deepest human-made point on Earth, a record it still holds in terms of vertical depth. And yet the real reason the Kola Superdeep Borehole became legendary is not only because of how far it went. It is because the deeper the drill descended, the stranger the Earth seemed to become. Scientists expected one world and found another. They expected certain layers, certain transitions, certain temperatures, and certain geological patterns. Instead, they encountered heat far beyond forecasts, deep fractures filled with fluid, evidence that challenged old seismic interpretations, and rocks carrying signs of processes far more complex than anyone had imagined. And then, around those scientific truths, another story grew in the shadows. A darker story. Rumors spread that strange sounds had been heard from the depths. Legends claimed the Soviets had dug so deep they had broken into hell itself. That legend was never science. But the fact that it survived says something important. The Kola Superdeep Borehole did what very few scientific projects ever do. It crossed out of laboratories and technical journals and entered the territory of myth. Because when humanity drills more than 12 kilometers into the Earth, the imagination follows. Tonight, we are going all the way down into that story, into the frozen frontier where the project began, into the Cold War ambition that made it possible, into the engineering challenge of drilling through ancient continental crust, and into the discoveries that forced scientists to rethink what lies beneath our feet. This is not just the story of the deepest hole ever drilled. It is the story of how the Earth fought back, how science collided with myth, and how one metal cap in the Arctic became the lid on one of the strangest places humans have ever tried to reach. If Earth has an archive written in stone, Kola was humanity's attempt to read a forbidden page. And the deeper they went, the more the planet answered in ways no one expected. To understand why the Kola Superdeep Borehole mattered, you first have to understand where it was placed. This was not an arbitrary patch of land chosen at random. It stood on the Kola Peninsula in the Murmansk region of northwestern Russia, north of the Arctic Circle, and near the borders of Norway and Finland. This is a severe landscape. Long winters, exposed rock, harsh winds, and a ground that carries the weight of deep geological time. The rocks beneath the peninsula are part of the Baltic Shield, one of the oldest continental crust regions on Earth, composed largely of ancient crystalline formations that preserve an immense record of the planet's early history. That alone made the region scientifically priceless. If you wanted to look deep into continental crust, not by imagining it from above, but by physically penetrating it, this was one of the best places on Earth to try. The Soviet Union understood that. During the 20th century, deep drilling was more than a scientific challenge. It was also a demonstration of technological power. The deeper a nation could drill, the more it could claim mastery over geology, engineering, and the hidden architecture of the planet itself. By the late 1960s and into 1970, the Soviet scientific establishment launched a program designed to explore Earth's interior through super deep drilling. The Kola project, often referred to as SG-3, became the flagship of that effort. Drilling began on May 24, 1970. The mission was breathtaking in its ambition: penetrate as deeply as possible into the continental crust and recover a detailed core record that could reveal the structure, composition, temperature, and physical behavior of rocks at extreme depth. That may sound abstract at first, but in reality, it meant something profound. For centuries, human beings had lived on the skin of the planet, measuring mountains, crossing oceans, and mapping continents, while knowing almost nothing about what truly lay below. Most of what geology understood about the deep crust came indirectly, through seismic waves, models, comparisons, and inference. Kola was different. Kola meant direct contact, not a guess, not an echo, an actual descent through the rock record itself. And there was another reason the site was so compelling. Scientists believed the continental crust in this region was roughly 35 kilometers thick. Even if the drill could not reach the mantle, which it never did, every kilometer downward promised a deeper and more direct look at how Earth's crust was really built. This was exploration in the purest sense. No astronauts, no submarines, no jungle expeditions. Just steel, heat, time, and a decision to keep drilling into darkness. And for a while, it worked. It is difficult to appreciate the scale of this achievement without stopping to think about what 12,262 meters really means. It is over 12 kilometers straight down, more than 40,000 feet into the crust of the Earth. Deep enough that if Mount Everest could be inverted into the ground from sea level, a significant fraction of that descent would still remain. The Kola Superdeep Borehole did not reach that depth quickly. It took years of drilling, redesigning, pausing, testing, and fighting a battle against the physical behavior of the planet itself. This was not simply a matter of making a drill bit longer. At such depths, everything changes. Temperature rises, pressure intensifies, rock behavior shifts, equipment strains, and the margin for error narrows dramatically. In 1979, the Kola project surpassed the previous depth record held by the Bertha Rogers Hole in Oklahoma. That moment alone was historic. Humanity had drilled deeper than ever before. But the Soviets did not stop there. By June 1983, the borehole had reached around 12,066 meters. By 1989, it achieved its maximum true vertical depth of 12,262 meters. In terms of vertical depth, no human-made hole has surpassed it since. That sentence deserves to be felt, not just read. Decades have passed. Technology has advanced. Nations have built longer boreholes in total length by drilling at angles for industrial extraction. But the Kola Superdeep Borehole remains the deepest point humans have ever reached directly beneath the Earth's surface. It still holds that vertical record. And yet records alone do not explain why this project became iconic. What matters is that every extra meter came at an increasing cost, not just financially, but physically and scientifically. Drilling into Earth is not like tunneling through stable, airless emptiness. The deeper you go, the more the planet resists. The temperature increase was one of the greatest enemies. Geological models had suggested one kind of thermal behavior, but deeper drilling revealed a far harsher reality. At around 12 kilometers, the temperature reached approximately 180 degrees Celsius, or 356 degrees Fahrenheit, far above the expected 100 degrees Celsius. That difference was catastrophic for the project's ambitions. At those temperatures and pressures, the rock did not behave like simple hard stone waiting to be cut. It began to behave plastically, creeping and deforming in ways that destabilized the wellbore. The Earth was no longer just resisting the drill bit, it was changing the battlefield itself. This detail is crucial because it reveals why Kola became both a triumph and a limit. Humans had reached astonishing depth, but nature had imposed a boundary that engineering of that era could not overcome. The project continued in modified forms for a time, and additional drilling branches were attempted, including a fourth hole begun in the early 1990s. But the thermal conditions were too extreme, and combined with the collapse of the Soviet Union and the loss of funding, the dream of going much deeper effectively ended. By 1992, drilling had stopped. The site eventually fell into disuse and later abandonment. But by then, the world's deepest hole had already changed geology forever. Before the drill descended, scientists did not enter the project blindly. They had models, expectations, seismic interpretations, and decades of geological theory guiding them. One of the biggest expectations concerned the structure of the continental crust itself. At the time, researchers anticipated that drilling would help confirm a relatively clean transition between major geological layers inferred from seismic data. In simplified terms, one expectation was that certain seismic boundaries corresponded to clear compositional changes in the rocks below. But one of the major lessons of Kola was that those interpretations were not as straightforward as they seemed. The borehole forced scientists to reconsider how seismic signals should be read and what those underground discontinuities actually meant. That is one of the most fascinating things about the project. It was designed to answer questions, and it did, but in doing so it also exposed how many assumptions were too neat, too simple, or just wrong. And this is where the Kola story becomes more than a technical record. It becomes a reminder that human beings often imagine the unknown as orderly until direct contact proves otherwise. We build clean diagrams. Earth gives us fractured reality. Another expectation involved the thermal gradient. Scientists had forecasts for how hot the crust would become with increasing depth, and while rising temperatures were no surprise in principle, the actual numbers encountered were significantly higher than expected. That change was not a minor inconvenience. It was one of the core reasons the project could not go on much farther. There were also expectations about rock porosity and permeability at extreme depth. At great depths, many models assumed that rocks would be tightly compacted and far less open to fluid movement than surface geology might suggest. But what Kola revealed was more complicated. Deep crustal zones showed evidence of fracturing, fluid pathways, and permeability associated with tectonic disturbances and hydrothermal systems. That finding mattered enormously. It meant that the deep continental crust was not simply a static, sealed archive of mineral matter. It was, in places, a more dynamic environment than many had imagined, shaped by fluids, deformation, and geological processes that remained active over immense spans of time. And then came another surprise. The project recovered evidence that pushed understanding of early life and ancient biological participation in rock formation into deeper and older contexts than many viewers might expect from a deep hole story. Reports associated with Kola have described microscopic fossils found at significant depth, while broader interpretations from the project also supported the idea that some early Precambrian metasedimentary rocks were formed with active participation of biological processes. This is where the story becomes almost poetic. Humans drilled downward into what many would imagine to be a lifeless geological abyss and found traces connected to life's ancient history embedded in the rocks. The deeper they looked into stone, the more they encountered echoes of biology. That is not hell, it is stranger than that. It is a reminder that Earth's crust is not just a pile of dead layers. It is a record of heat, pressure, water, chemistry, fracture, mineral circulation, and life itself leaving fingerprints in places that feel almost impossibly remote from the surface world we know. The Kola Superdeep Borehole was not famous because it touched a single miraculous object at the bottom. Its importance came from a pattern of discoveries, each one adding to a larger picture of a crust more complex, more fluid, and more surprising than anticipated. One major result involved the structure of the crust and the reinterpretation of deep seismic data. The borehole provided direct samples and measurements that forced scientists to rethink how certain seismic boundaries should be understood. Features once interpreted as simple compositional transitions did not always match the actual rocks encountered. That may sound technical, but its meaning is huge. Imagine trying to understand the inside of a mountain by listening to echoes, then finally drilling into it, and discovering the echoes had been shaped by pressure, fractures, metamorphism, and physical behavior you had not fully accounted for. Kola did that to deep crustal science. Another major result involved fluids in the deep crust. Researchers found evidence that rocks at great depths were not as sealed off as many would assume. Increased porosity, fracturing, and permeability in some deep zones suggested that fluids and hydrothermal solutions could move through crustal environments once thought to be relatively closed. Then there was mineralization. Studies from the Kola cores identified multiple types of ore mineralization through the borehole section, including copper-nickel ore bodies, and later research on deep cobalt and palladium mineralization. Even more striking, a 2020 study reported exceptional concentrations of gold nanoparticles in fluid inclusions from gold-bearing rocks recovered between roughly 9,500 and 11,000 meters depth. Gold deep in the crust? Not as fantasy treasure, but as a clue to how mineral-bearing fluids move and concentrate elements under extreme geological conditions. That is the kind of discovery that does not make a myth smaller. It makes reality more astonishing than myth expected. And yet perhaps the most dramatic finding, the one that practically writes its own cinematic sequence, was the heat. At around 12 kilometers depth, the borehole encountered temperatures of about 180 degrees Celsius, far above prior expectations. At those conditions, deep rock began to behave less like a rigid wall and more like a slowly deforming material. That is a terrifying image in its own way. Not fire, not lava, not some glowing underground cavern, but solid rock becoming mechanically unstable under the combined force of temperature and pressure. The Earth was not opening dramatically. It was quietly refusing to remain predictable. And that refusal is one of the true themes of the Kola story. Human beings went down expecting confirmation, and instead received correction. They expected a cleaner structure, a calmer thermal profile, and more straightforward deep conditions. Instead, they found an environment where theory had to be revised by direct contact with the crust itself. That is the point where science becomes genuinely dramatic. Not when it proves what was already expected, but when the evidence forces the model to break. The Kola Superdeep Borehole might have remained an extraordinary but mostly technical scientific achievement if the story had ended there. But Kola did not stay inside scientific literature. It escaped into folklore. At some point, stories began circulating that Soviet scientists had lowered microphones into the borehole and recorded horrifying screams from beneath the earth. The place became associated with the phrase, "the well to hell," or "the hole to hell," a legend that spread widely through sensational media, religious retellings, and early internet culture. There is no scientific basis for that story in the published research surrounding the borehole. The legend belongs to the realm of myth and media amplification, not geology. But we should not dismiss the myth too quickly, because myths survive for reasons. The idea took hold because the actual facts were already eerie enough to invite exaggeration. A sealed opening in the Arctic, a hole deeper than any other on Earth, temperatures rising beyond forecasts, a Cold War scientific site abandoned after the collapse of the Soviet Union. Even without demons, the atmosphere was already there. What makes Kola compelling is that reality and legend sit side by side without fully blending. The myth gives the story darkness. The science gives it depth. And together they create something rare. A place where hard data and human imagination orbit the same void. There is something deeply revealing in that. When people hear about an experiment that drills 12 kilometers into the Earth, they do not only ask what the scientists measured, they ask what else might be down there. That instinct matters for storytelling, because the most powerful documentaries do not just deliver facts, they map the border between what is known, what is feared, and what is still unresolved. The Kola Superdeep Borehole sits exactly on that border. By the early 1990s, the Soviet Union was collapsing. Funding evaporated, and the project was brought to a halt. The site later fell into disrepair and abandonment, leaving behind an industrial ruin with almost mythic emotional force. An unfinished descent, a world record, strange scientific results, and a silence deep enough for stories to fill. That is how legends are born. If part 1 was about ambition, then part 2 is about resistance. Because once the Kola Superdeep Borehole pushed past the symbolic frontier of being the deepest, the story changed. It was no longer simply a triumph of drilling. It became a confrontation with the hidden behavior of the Earth itself. And what made that confrontation so unsettling is that the planet did not resist in the way most people imagine. There were no underground caverns of fire, no sudden abyss opening beneath the drill rig, no cinematic collapse into some glowing inferno. The resistance was quieter than that, and in some ways far more disturbing. It came in the form of heat, pressure, fluid movement, rock deformation, and evidence that the deep crust was much less rigid and much more chemically alive than older models had implied. At first, the project seemed to confirm the confidence of those who believed the deep crust could be steadily penetrated with enough patience and engineering. But depth has a way of exposing optimism. And as the drill descended farther into the ancient crystalline rocks beneath the Kola Peninsula, the Earth began to answer with conditions that were not merely difficult, but destabilizing. The most famous technical shock at Kola was temperature. Geologists and engineers had expected the deep crust to grow hotter with depth, of course, but the actual thermal increase turned out to be far more severe than the working models had predicted. At the deepest levels, around 12 kilometers down, temperatures reached approximately 180 degrees Celsius, or 356 degrees Fahrenheit. That number is not just impressive. It is the number that changed everything. The original expectation had been closer to 100 degrees Celsius at that depth. Instead, the rock was nearly twice as hot as forecast. That is the kind of discrepancy that does not merely slow a project down. It rewrites the rules of what the project is physically capable of surviving. At extreme depth, heat is not a background condition. It affects every component of the operation. Drill bits wear faster. Pipes deform under stress. Borehole walls become harder to stabilize. Fluids behave differently. Measurements become more difficult. Margins shrink. And then there was the rock itself. Under those high temperatures and pressures, the rock near the bottom of the borehole began to behave plastically, slowly creeping and deforming into the wellbore, instead of remaining a stable, rigid boundary. That single detail carries enormous dramatic power, because it means the scientists were no longer drilling through a passive material. They were drilling through rock that was beginning to move back against them. Imagine the psychological weight of that. You spend years pushing steel deeper into the earth, building your knowledge meter by meter, and then the planet begins to close around your path. Not explosively, not theatrically, but steadily, almost patiently, as if depth itself were denying entry. This is one of the reasons the Kola project feels so much more haunting than an ordinary engineering record. The deeper the scientists went, the less the Earth resembled a machine that could be decoded by brute persistence. Instead, it began to resemble a living system of stress, heat, chemistry, fracture, and motion, one that could not be bullied by human expectation. This is where many documentaries make a mistake. They treat the halt at Kola as if the project merely got too hot and stopped. But that flattens the drama. The truth is deeper. The rising temperature did not only damage equipment, it transformed the physical behavior of the environment the equipment depended on. Past a certain threshold, this was no longer a drilling challenge in the conventional sense. It was a fight against an underground world whose properties had changed. And once that happened, the dream of pushing dramatically farther downward began to die. If the heat barrier challenged engineering, the fluid evidence challenged intuition. One of the most surprising outcomes associated with the Kola Superdeep Borehole was the indication that water, or more precisely deep fluid presence, existed in ways many did not expect in supposedly dense, old crystalline rock. To a casual viewer, that may sound trivial. Of course, there is water underground. Wells reach water all the time, but what Kola revealed was not ordinary shallow groundwater and porous sediment. It pointed to fluids deep within fractured crystalline rock, trapped and moving through structures at depths where older assumptions often imagined a far more sealed environment. Some reports describe water pooling several kilometers below the surface, rising through fractures in granite until it was blocked by less permeable layers above. Other explanations emphasize that hydrogen and oxygen may have been squeezed from mineral structures under deep conditions, contributing to the fluid story in a way that challenged simpler surface analogies. However, one frames the mechanism in a public-facing documentary. The core idea is astonishing and solid enough to use carefully. The deep crust was not dry, dead, and inert in the simplistic sense many people would imagine. It held fluid pathways, fractures, chemical activity, and subsurface circulation patterns that forced geologists to rethink the plumbing of the continental crust. That matters because water changes everything underground. It alters minerals. It transports heat. It participates in hydrothermal reactions. It opens the possibility for gas generation, chemical transformation, and ore-forming processes over geological timescales. And it adds another layer of unease to the Kola story. Because deep below a frozen Arctic surface, where people might imagine only compressed stone, the borehole revealed evidence of circulation and trapped fluids in an environment far more dynamic than the word bedrock seems to imply. In other words, the rock was not just deep, it was active. That makes Kola feel less like a needle piercing a static shell and more like a probe entering a hidden system. Then there were the gases. As drilling progressed, hydrogen gas bubbled up from the well, along with helium, nitrogen, and carbon dioxide. To people already inclined toward myth, this kind of phenomenon practically writes its own rumors. Boiling mud, strange gas, enormous depth, abandoned Soviet machinery in the Arctic. All the ingredients were there. But the scientific meaning is far more interesting than the supernatural one. Hydrogen at depth is not evidence of hell. It is evidence of geochemical processes that can operate in the crust under specific conditions. One explanation, often connected to hydrogen generation in geological settings, is serpentinization, a process in which hot water interacts with iron and magnesium-rich minerals, altering them and releasing hydrogen as a byproduct. Even if one does not overstate the exact local mechanism for every gas observation at Kola, the broader point remains powerful. The deep crust was chemically active in ways visible at the surface through the behavior of the drilling system. That is a beautiful documentary moment, because gas is invisible until it announces itself. And at Kola, the invisible kept announcing itself, not as monsters, not as demons, but as chemical signatures of a world that ordinary human senses were never meant to experience directly. The drilling mud itself became part of the story. Some descriptions reported that it appeared to boil as hydrogen flowed from the system. Visually, that is the kind of detail that makes science cinematic without inventing anything, because it tells the viewer that even the materials designed to control the experiment were being altered by the conditions below. The more the borehole penetrated the crust, the more the crust responded. And this is a key storytelling principle you can lean into hard in your final video. The Kola borehole was not a silent act of extraction. It was a dialogue. Humans sent down steel and mud. The Earth sent back heat, gas, fluids, fractures, and 1,000 reasons to revise the map. Among the most surprising claims tied to Kola, and one of the easiest to mishandle if told badly, is the discovery of microscopic fossils at great depth. According to widely cited summaries of the project, around 6.7 kilometers down, researchers identified 24 species of ancient microfossils, preserved within organic compounds that appear to have helped shield them from extreme pressure and temperature. If true, and it is often repeated in educational and reference summaries of the borehole results, this is one of the most mind-bending images in the entire story. Not giant skeletons, not subterranean monsters, but tiny traces of ancient life carried down into a geological environment that most people would instinctively describe as sterile and unreachable. These were not fossils in some shallow beach cliff or exposed canyon wall. They were associated with rocks from far below the surface, at depths where the human imagination usually stops picturing life entirely. And that matters because it shifts the emotional tone of the story. Kola is often presented as a descent into fear, depth, darkness, pressure, rumor, heat. But the fossil evidence introduces another dimension. It becomes a descent into memory. Think about it. The drill did not only penetrate distance, it penetrated time. Kilometer after kilometer, the project passed through a vertical archive of Earth history, and within that archive were traces of ancient biological worlds preserved under conditions that seem almost impossible. In narrative terms, this is pure gold, because it allows your documentary to pivot from menace to wonder without losing intensity. One moment, the viewer is picturing plastic rock and boiling mud. The next, they are being asked to imagine the microscopic remains of life buried in the deep crust, surviving across almost incomprehensible spans of time. That is exactly the kind of tonal contrast that channels like the one you analyzed use so effectively. Tension, then revelation. Fear, then awe. Danger, then a broader cosmic perspective. And the deeper meaning is hard to ignore. We often imagine the Earth as divided into surface life above and geological silence below. But Kola blurred that psychological boundary. It suggested that even in the deep mineral architecture of the planet, life's history remains entangled with the stone. Perhaps the most important lesson of the Kola Superdeep Borehole is not any single number, fossil, or gas signature. It is the way the project forced science to correct itself. This is worth dwelling on, because it is where the story becomes bigger than drilling. Before Kola, much of what scientists knew about the deep crust was inferred from indirect evidence, especially seismic interpretation. Those methods were powerful, but Kola offered something rare: direct sampling, direct measurement, direct contact. And direct contact has a brutal honesty. It strips theories of their elegance and asks whether they survive reality. In multiple ways, Kola showed that some models were too simple. The expected relationship between seismic boundaries and rock composition did not line up as neatly as once believed. The thermal profile was harsher than forecast. The crust contained fractures, fluids, and permeability in places where many expected tighter closure. The deep environment was more chemically expressive, more mechanically unstable, and more structurally complicated than older assumptions had allowed. That is not failure. That is science at its most honest. The point of a great experiment is not to flatter theory, it is to confront it. And Kola confronted it harder than almost any drilling project before or since. This is why the borehole matters even now. It is easy to see it as a Cold War relic, a Soviet-era curiosity capped and abandoned in the Arctic. But that reading misses the larger significance. Kola remains one of the clearest demonstrations that the Earth beneath us is not a passive block of geology waiting to be charted by confidence alone. It is a layered, reactive system whose true complexity only reveals itself under direct pressure. In that sense, the borehole did not just go down into the crust. It drilled into the limits of human assumption. And what it found there was not certainty, it was revision. By the late 1980s and early 1990s, the project was facing more than technical problems. The heat at depth had already made further progress extraordinarily difficult. Borehole stability was under constant stress. Equipment limits were real. And beyond the science, history itself was beginning to shift. The Soviet Union was entering its final years. Funding structures were under strain. National priorities were changing. Massive scientific projects that once served not only research goals but prestige and state identity became harder to sustain. Drilling ultimately stopped in 1992. The record remained, but the dream of going much deeper ended there. A cap was placed over the opening. The facility entered decline. Machinery aged, buildings deteriorated. The world's deepest doorway into the crust became, in visual terms, a relic. There is something profoundly cinematic about that ending. Not an explosion, not a heroic final breakthrough. Just abandonment, rust, Arctic weather, and one of the greatest scientific descents in history reduced to silence. But that silence should not be mistaken for irrelevance. If anything, it makes the story stronger. Because Kola feels unfinished in exactly the right way. Not as a failed fantasy, but as a boundary marker. It shows how far humanity could go with the tools and models of its time, and where the Earth forced that effort to stop. And the most unsettling truth may be this: the hole is sealed, but the questions are not. By the time the Kola Superdeep Borehole fell silent, it had already become two different things at once. In the world of science, it was a landmark experiment in deep crustal research, one that forced experts to revise assumptions about heat, fluid movement, rock structure, and the physical behavior of the continental crust. But in the public imagination, it became something stranger, a sealed wound in the Arctic, an unfinished descent, and a place where fact and fear could live side by side. That dual identity is why Kola still matters. not just because it was deep, but because it reached the rare point where science becomes myth-shaped without ever surrendering its truth. The most surprising part of the Kola story is that its core record has not truly been erased. The hole reached a maximum true vertical depth of 12,262 meters in 1989, and in terms of depth below the surface, it remains the deepest artificial point ever made by human beings. That distinction matters. In later years, some industrial wells exceeded Kola in total measured length by drilling at angles and extending laterally through rock, but those did not surpass Kola in vertical depth. So when people call Kola the deepest hole on Earth, and that is still true in the most dramatic and intuitive sense, no one has gone farther straight down. And that is extraordinary when you pause to consider what it means. Humanity has launched spacecraft beyond the solar system, built machines that see across the universe and mapped the ocean floor with increasing precision. Yet beneath our own feet, the deepest direct vertical penetration into the planet remains just over 12 kilometers. That is barely a scratch in planetary terms. Earth's continental crust can reach around 35 kilometers thick in regions like the Kola Peninsula, and the mantle lies far deeper below. In other words, even at its maximum depth, Kola was still only partway through the crust. This is one of the most humbling facts in the entire story. The project was one of the greatest drilling efforts in history, and yet even that astonishing descent did not come close to the mantle. The Earth is so vast, so layered, and so hostile to direct penetration that one of humanity's greatest subsurface achievements still ended far above the deeper boundaries we dream of reaching. That is not failure, it is scale. It is the planet reminding us that depth is a different kind of frontier. Many nations and research programs have drilled deep wells for energy, science, or engineering since the Soviet era. But almost none have captured the same symbolic power as Kola. And that is because Kola was never only about geology. It was geology fused with timing, location, ambition, and atmosphere. It was born in the Cold War, when technological achievement carried ideological weight. It was placed in the Arctic, in a landscape already primed for isolation and severity. It pushed deeper than anyone had ever gone. It encountered surprising scientific results. It was halted by heat and limits that felt almost metaphysical in their finality. And then it was abandoned, capped, and left behind as the Soviet world that created it disappeared. That combination is almost impossible to reproduce. Modern drilling can be more advanced, more efficient, even longer in total measured distance. But Kola has something modern projects rarely achieve: narrative gravity. It feels like a lost chapter from a civilization that tried to pierce the earth and was forced to stop. That is why the site retains such emotional power. It is not just a record holder. It is a monument to unfinished curiosity. And in storytelling terms, unfinished curiosity is stronger than closure. A mystery solved is satisfying. A mystery sealed with a metal cap in the Arctic is unforgettable. No discussion of Kola is complete without confronting the myth directly. At some point, especially in the 1990s, stories began spreading that Russian scientists had lowered a microphone into the borehole and recorded the screams of the damned. The story evolved into one of the most famous modern urban legends linked to science: the claim that the Kola Superdeep Borehole had broken into hell itself. The legend is fiction. There is no credible scientific evidence that such sounds were recorded, and later analysis tied the famous hell sounds audio to edited effects rather than some authentic subterranean recording. But the myth deserves attention precisely because it attached itself so effectively to a real scientific project. It did not arise in a vacuum. It attached itself to Kola because Kola already possessed the perfect psychological ingredients: immense depth, Cold War secrecy, unexpected heat, strange gases, abandonment, and a location remote enough to let imagination outrun documentation. In other words, the myth did not replace the science. It parasitized it. And that tells us something important about how humans respond to the unknown. When science ventures into spaces that ordinary people cannot visualize or verify for themselves, narrative rushes in to fill the emotional gap. The deeper the hole, the darker the story becomes. There is also a deeper symbolic reason the well-to-hell myth survived. Across cultures, the underground has long been associated with the hidden, the forbidden, the dead, and the punished. The Kola project did not create that symbolism. It merely activated it in modern technological form. A medieval imagination might have pictured a cavern beneath the world. A 20th century imagination pictured drill rigs, microphones, and Soviet engineers accidentally recording what ancient myth had only imagined. That is why the Kola borehole occupies such a rare cultural space. It is one of the few scientific projects that became legendary not because the science failed, but because the science was real enough to make the legend believable. Once you strip away the myth, what remains is something perhaps even more powerful. Kola tells us that the earth below our feet is still, in many respects, a frontier. We map its surface with satellites, model its interior with seismology, and simulate its behavior with computers, but direct access remains brutally limited. That is what makes the borehole so profound. It represents one of the few times humanity physically entered the deep continental crust far enough to be corrected by it. Not from orbit, not through remote sensing alone, through contact. And what did the Earth say back? It said, "Your models are incomplete." It said, "Heat rises faster than you hoped." It said, "Rock is not always rigid where you want it to be." It said, "Fluids move where you thought they could not." It said, "Chemistry continues in darkness." It said, "Ancient traces of life may survive where your imagination expected only sterile stone." That is a remarkable response from a hole in the ground. But Kola was never really just a hole. It was an instrument for forcing humility. This is why the story works on so many levels. At the surface, it is a Cold War engineering saga. At the scientific level, it is a deep crust experiment that produced lasting geological insight. At the mythic level, it became a vessel for ancient fears projected onto modern technology. And at the philosophical level, it is a reminder that the world beneath us remains more alien than we like to admit. Space often gets all the poetry, but in some ways, the underground deserves just as much. We look upward and see distance. We look downward and imagine certainty, solidity, foundation. Kola shattered that illusion. It showed that beneath the ground we walk on lies not a simple reassurance, but another realm of pressure, heat, fracture, and unanswered questions. Today, the Kola Superdeep Borehole is no longer an active frontier. The site was abandoned, the operating company was later liquidated, and the opening itself was sealed with a metal cap. Much of the infrastructure fell into decay, and visitors who reach the remote site describe a place that feels more like a relic than a triumphal monument. That image is unforgettable. One of the boldest scientific descents ever attempted does not end in a gleaming museum or a pristine research center. It ends in rust, emptiness, weather, and a lid. And somehow that feels right. Because the Kola story was never supposed to feel complete. If it ended neatly, it would lose part of its power. What gives it lasting force is the sense that we reached downward, learned something profound, and still stopped far short of full understanding. That is the emotional truth of the metal cap. It does not say, "We finished." It says, "We got this far." And this far turned out to be enough to change geology, ignite myth, and remind humanity how little of its own planet it has truly touched. Somewhere on the Kola Peninsula, beneath Arctic wind and old Soviet ruin, the deepest point ever reached by human hands still descends into the earth. It is silent now, sealed, forgotten by many, but not erased. More than 12 kilometers below that rusted cap lies a path cut through ancient crust, a record of heat, fracture, chemistry, and time. No one stands at the bottom of it. No camera has shown us what down there looks like in any human sense. All we have are cores, measurements, scars in the rock, and the knowledge that the Earth became stranger the deeper we touched it. That may be the real legacy of the Kola Superdeep Borehole. Not that it proved some myth, not that it conquered the planet, but that it exposed a truth far more unsettling and more beautiful. Even beneath our feet, on the world we believe we know best, there are depths that still resist us. And perhaps that is why the story endures. Because the deepest hole on Earth did not just open the crust, it opened the imagination. It reminded us that the planet is not only where we live, it is also where we are still trying, very slowly, to arrive.